Hello everyone, welcome back, and we keep doing the sum and difference cubics. All right, first thing first, and also we actually learn some solving the polynomial equation as well today. Okay, so those two please write down in your reference book, and they're gonna help you anytime. And then let's have a look the rational root theorem looks like. So what is rational root theorem? So we have the polynomials of the degrees, and then alpha and beta integer is highest common factor, which is like alpha and beta, and they can be relatively prime. So which is like if you had beta x plus alpha is a factor of the px, then the beta divided by x and alpha divided by x is 0. Okay, this sounds very, very tricky, but what does that mean actually? Let's have a look at the question. Um, First thing first, let's try we set up as if there's x equal to 1 and p1 equal to 8. That's not equal to 0. That means not a factor. And let's try the negative 1. And once I substitution the negative 1 is 3 times negative 1, negative 3 plus 8 minus 2 minus 5. That's not equal to 0 as well, that because they're equal to negative 2. So, and let's try another one. Maybe let's try p to the 5 and 125 and times 3. And that's the 425, and then that equal to, and definitely that's not equal to 0. Okay, so this is no integer. Now we're gonna figure out how we actually try to find our little fraction to become the factor. So that's why I want to circle this one. It's a factor of the polynomial equations. This one is divided by an, which is that is your this number, which is highest the degree. Okay, so beta is equal to 3. And alpha is the a0, which is the last integer, is negative 5. So we could think about it. Remember the reminder theorem we do is p to the alpha over beta, right? Perfect. That means we're gonna figure out is how that gonna work. This one, if we're using by hand, and please give a try, and all of a sudden actually I figure out that equal to 0 from nowhere, and it equal to 0. Yeah, but actually that equal to 0. So therefore beta x plus alpha, which is equal to 3x plus 5, 8 factor. And now we can using the long division to find the rest of it. So we could do is 3x plus 5 and 3x squared plus 8x squared plus 2x minus 5. And that equal to x squared and 3x cubed plus 5x squared. That equal to 3x squared plus 2x. So plus x. That's 3x squared plus 5x. And that equal to minus 3x minus 5. And that will equal to minus 1. Minus 3x minus 5. Perfect. We figure out that's your remainder is equal to 0. And then we could rewrite as 3x plus 5 x squared plus x minus 1. And for x squared plus x minus 1, we could do something complex square to showing you. And that's a very good practice with a complex square. So we could do x squared plus x and plus 1 over 4 minus 1 over 4 minus 1. So that equal to 3x plus 5. And that equal to x plus half squared minus 5 over 4. But that was the medium bracket. All right, and then we could do is the perfect square, 3x plus 5, and that's x plus half, and plus root 5 over 2, and another one is x plus half minus root 5 over 2. There you go. That's your another factors. So that's a rational root of theorems. Looks a little bit tedious, but actually you can do by hand. But I will show you. We have another quick way, which is we're gonna using CAS calculator in the end. I will show you how, but I'm gonna definitely show you how to do it. And now let's try this one. Okay, we had x cubed minus 4x squared minus 11x plus 30. And to solve the equation that equal to 0, okay, perfect. Now we're gonna find out our first factor. Let's try P1. 1 minus 4 minus 11 plus 30. That's now equal to 0. Let's try minus 1. Now equal to minus 1 minus 4 plus 11 plus 30. That doesn't equal to 0 as well. Maybe let's try the P2, maybe. And that equal to 8 minus 16 minus 22 plus 30. That equal to 0. Perfect. Lucky me. Set try and find out. All right. That means x minus 2 is your factor. Now let's try with x minus 2 and x cubed minus 4x squared minus 11x plus 30. That's pretty good, and I'm going to using the different colors. Maybe I try something with purple. First one, x squared, x cubed minus 2x squared. So that equal to minus 2x squared plus minus 11x. And minus 2x, so minus 2x, which is minus 2x squared plus 4x, so which is minus 15x and plus 30, so minus 15. So minus 15x plus 30, that equal to 0. Perfect. That's the remainder equal to 0. And we are on the right track. So x minus 2, x squared minus 2x minus 15 equal to 0. And x minus 2. So how we do this one? Easy, because we're going to do cross product rule. And that equal to x minus 5 and x plus 3. And that equal to 0. And now when x equal to 2, px2 equal to 0, x equal to 5, p5 equal to 0. And x equal to minus 3, and p minus 3 equal to 0. That's our solution. All right, there you go. That's how you solve the solution with the polynomial equations. And we could do the other way, which is the much easier way, which is CAS calculator. And I will show you how during the class. All right, that's all for 4D. And hopefully you guys learned today. And I'll see you guys next time.